Have you ever just stopped and really looked at your phone? I mean, really marveled at it. Every single year, they get ridiculously fast, the cameras get way better, but the phone itself, it just gets thinner, or at the very least, no bigger. It's this little engineering miracle we carry around every day. So today, we're going to pull back the curtain and uncover the brilliant, hidden architecture that makes it all possible. It all starts with what you could call a paradox, a central mystery that engineers have been wrestling with for more than a decade now. And here it is, the big question we're going to unpack together. It just seems impossible, right? More power, more features, that should mean more stuff. And more stuff should take up more space. But that's not what's happening. So where in the world does it all go? What you're looking at here is basically the front lines of a constant war happening inside your phone. Seriously, think of it as a war for space. The battery is screaming for more room, the camera system is getting more and more complex, the processor needs more support components. Every single part is in a bare-knuckle brawl for every last square millimeter. This relentless war for real estate forced a totally new way of thinking. Engineers realized that when you run out of room to build out, well, you've got to start building up. And this quote just nails it. It's the perfect analogy for the huge conceptual leap they took. It's a simple idea, right? Just stack it. But the execution is incredibly complex, and it completely changed how a phone's electronic brain is built from the ground up. So here's what they actually do. Engineers take the main circuit board, the motherboard of the phone, and they literally split it into two separate layers. Then they fold one on top of the other, creating the sandwich board. It's the key to the whole thing. It lets them cram nearly double the components into roughly half the horizontal space. And this right here, this is the aha moment. What looks like one impossibly packed circuit board is actually two boards, neatly stacked. By shifting from a flat, two-dimensional layout to a three-dimensional one, they essentially built a tiny skyscraper for all the silicon, freeing up so much valuable real estate inside the phone. But okay, stacking the boards solves one problem, but it creates a whole new one, a massive one. I mean, once you've got two separate boards, how do you get them to work together as a single unit? Exactly. It's not like you can just use some glue and call it a day. You've got these two highly complex circuits that now need to communicate perfectly to function as one unified brain. So how in the world do you connect the thousands of pathways between them? The answer is this unassuming little component called the interposer. Now, I know it might look like just a simple frame, but don't let its looks fool you. It is not just a spacer. This thing is the central nervous system of the entire sandwich, a super complex, multi-layered circuit board in its own right, acting as the ultimate bridge. So its job is kind of threefold. First, it holds the two boards apart at a very precise, perfect distance. Second, it gives the whole sandwich its structural strength. But most importantly, it's packed with thousands of microscopic electrical lines that let the top and bottom boards talk to each other like they're one piece. And the level of precision we're talking about here is it's staggering. Every single one of those connection points has to line up perfectly with pads on both boards. We are talking about accuracy on the micron level. That's 1/1,000,000th of a meter. Any tiny mistake, if you're off by even a fraction, the entire board is useless. Toast. But you know how it is. An engineering solution this brilliant, this clever, it doesn't come for free. Every major innovation comes with some serious trade-offs. And this table really lays out the pros and cons perfectly. On the one hand, yeah, you get absolutely incredible space savings. But on the other hand, the manufacturing costs go through the roof. Heat becomes a major problem. And trying to repair one of these things, it's a nightmare. This is why you usually only find this tech in the most expensive flagship phones. And that heat problem leads to something engineers call the small oven problem. You're cramming all these powerful heat-generating chips so close together, the heat gets trapped right in between the layers. Have you ever been gaming or shooting a long 4K video and your phone gets really hot and starts to slow down? Yep, that's thermal throttling, and it's a direct result of this sandwich design. And this brings us to a huge issue for us, the people who actually own these things. To fix one tiny little component that fails on an inner layer, a repair tech would have to desolder and separate the entire sandwich, a procedure that has a crazy high risk of breaking the whole thing permanently. So what's the result? Most of the time, the entire very expensive board just has to be thrown out and replaced. So you might be wondering, with all these challenges, the heat, the cost, the repair nightmare, why on earth do companies still do it? Well, let's zoom out and look at the ultimate payoff. And the answer? really is simple. They do it for us. The space they save by building that silicon skyscraper isn't just left empty. No way. It's immediately filled with all the things we demand. A bigger battery that actually lasts all day, a more advanced camera system that takes unbelievable photos, or new sensors that unlock cool new features. That's the trade-off they're willing to make for us. So, this all leaves us with a big question for the future. As this two-story design starts hitting its physical limits with heat and repairability, what comes next? Do we see them try to build a three-story skyscraper? Or are we on the verge of a totally radical new architecture? Something like flexible circuits you can fold like paper, or maybe even 3D printed circuits built right into the phone's body. One thing's for certain, the war for space is far from over.